final scent in the package potpourri, so hopefully it's a pleasant odor. I'm going to talk to you about tcl'Rmq library I wrote. Where is it? You can get it here. That's github.com/flightaware/tcl'Rmq. Full documentation of the library there in the README. I have examples for all of the typical RabbitMQ tutorials that are already in a bunch of other languages, and some additional examples. At the bottom here, sorry, the fonts are really small. It says package require RMQ, so all of the library exists in that namespace. So what is it? It's a pure Tcl library. There's no bindings. I'm not wrapping a C library. There is a C library for RabbitMQ, but it doesn't support asynchronous operation out of the box. You'd have to add something like libevent, which I didn't want to do. There is a nice C++ library for RabbitMQ, but I didn't have much success trying to create a wrapper for that. And there's pure libraries in many other languages that seem to work great, so I figured might as well write one for Tcl. Currently, Tcl has some distributed messaging support for something like 0MQ, and there's the Kafka Tcl, but no RabbitMQ. There was a wrapping over the C library, probably put out years ago, but it was never fully implemented, and it doesn't work very well. So this library is fully asynchronous. There's no blocking I/O whatsoever. It's very callback based. I'll have many examples coming up. It only right now supports AMQP 091, which is the main one, so it's not too big of a problem. Part of the future work would be to implement maybe 1.0, but that deviates very heavily from this. So I didn't see much a reason to do that. By a show of hands, how many people have heard of RabbitMQ? How many people have used it? Is that everyone? Just one, couple? Okay. Cool. All right. AMQP first. It's the Advanced Message Queuing Protocol. So it's a protocol for using distributed queues, putting messages onto a queue on probably a remote server from the process that put the message on, and also taking messages off and doing some processing with them on a machine that's separate from the RabbitMQ server. It's an open standard. The version that I'm using, the 091, was formalized in 2008, and it was developed as a collaborative effort. Red Hat, Cisco, and JP Morgan were some of the big technical contributors to it. It's a binary application layer protocol, so it's at the top layer in the OSI model, and it runs over TCP. The semantics of the protocol itself is AQMP provides a series of methods and classes, so it's sort of defined in an object-oriented way. So it's very readable spec if you ever need to use it. RabbitMQ is a particular implementation of AQMP. It's open source. It's written in Erlang. It's been around for 10 years, maybe almost 10 years. It's very actively developed and maintained. It's well documented. It's battle tested. You can have distributed operation at the client level, obviously, but also at the server level, you can build clusters. It's very easy to set up and easy to maintain. It adds a number of nice protocol extensions, which I'll mention in passing as we go. And it comes out of the box with really nice management tools and other plugins. So, sorry, this font's pretty bad on here. But task 0 is making a connection to the server. And here's some example code for how to do that. You require the RMQ package. Can I make this font any bigger? Okay, come on. Yeah, probably. Well, you create a login class. So the library itself uses tcl'00 very heavily, but there are only sort of 3 main classes that you need to use. One is a login class for supplying credentials. The other is a connection class, which actually makes the TCP connection to the RabbitMQ server. And then there's a channel class, which every connection has a series of channels that you can create for actually doing most of the useful work with RabbitMQ. Okay, so RabbitMQ itself and AQMP is a little bit more than your standard FIFO that you learn about in the data structures class. Sure, you put and get messages off a queue, but it has a slightly altered interface that's a little different from the typical. What's different about it is that it adds a new layer of indirection. You don't actually put data directly onto a queue. You send messages instead from to an exchange. An exchange is something that you have to declare, and it's something that's taken care of by RabbitMQ. And then the exchange itself decides which queue to put the message in. So when you send a message to an exchange, you tell it which queue you want it to go to and which routing, and you give it a routing key. And that controls where it goes, and it lets you, it gives a lot of the power to RabbitMQ and to the whole AQMP. I got a little cut off here, but there's several different types of exchanges, and they all sort of differ based on the way that routing works. So creating an exchange is very simple. When the channel is opened, we set a callback, in this example called declare exchanges. And in there, you're passed in that callback a reference to the channel object. And you just use the exchange declare method that's defined on all the channel objects. It's pretty simple. It takes an exchange type, an exchange name, and some flags. And the flags let you define some things like, in this case, I use the exchange durable flag. So this exchange will persist after restarts. And then after you define or declare an exchange, you declare which queues you want to have. And the queue declare is another method that's used, and it's defined on channel objects. And it takes some flags as well. One of these is durable, so these queues will persist after reboots. They'll stick around. Okay. Another flag that you can use for declaring queues is exclusive. So this queue will only be used by a single consumer. All of the different queues or flags that are supported are all contained in the README and the GitHub repo. And then another important concept after you declare exchanges and queues is to define your bindings. And this connects the exchanges and the queues together, and is what actually allows you to put messages and data onto a queue. So that is done through a queue bind method that's also defined on channel objects. So there's exchanges, there's queues, pretty easy to do, pretty easy to use. And then once you've done that, you can actually put data onto the queue, or onto one of the queues through the use of an exchange. The method in AQMP and the protocol that's used for putting data onto a queue is called basic publish. And the channel object in the Tcl RabbitMQ library defines a basic publish method. It defines a method for every single AQMP method. So if you read the spec and you want to use something that you find there, it translates very easily into in this library. So in this case, when we're publishing, we have basic publish, we have the name of the exchange, and then we have a routing key. In this case, it's tcl.conference.star. One of the exchange types is a topic exchange. And in topic exchanges, the routing keys are all strings that are separated by dots. And then when you route to those exchanges, you can use wildcards. So tcl'.conference.star would go to any binding for any queue that started with tcl.conference.
Does it go to just one or all of them, or?
It depends on what bindings you set up. So you can arbitrarily set up whatever type of topology that you want.
So it could be a broadcast.
Yes, yes. There's one specific type of exchange called a fan-out exchange, which is used specifically for that purpose. It's just a public broadcast that goes to everybody.
But if it's not a broadcast and there are multiple ones, I guess the exchange sets the policy of which one gets it?
Okay, yes. So for which consumer actually picks it up. So the question is, if you have multiple consumers that are all pulling data from the same queue, which one gets what? For the fan-out, they would all get it. They see everything. For the other exchanges, like a direct exchange, the topic, or the header exchange, it depends on a few things. It's mostly round robin, but there's a setting you can set per consumer called a prefetch count. And that's the number of unacknowledged messages that a consumer can have at one time. And that will control the number of messages that they'll get at once before it moves on to the next consumer. So in this example as well, before we actually publish anything, something that's nice that RabbitMQ adds that's not in the actual specification are publisher confirmations. So when you're publishing data to a durable queue, one that you want to persist through reboots, and you want it to actually write the messages in the queue to disk so they survive and so they're durable, you can get acknowledgments back from the server when it's actually persisted a message to disk. So this lets you know where you are in whatever stream of messages you're publishing to a queue, so you can continue after a reboot or a crash or what have you. And to get those, all you do in this library is you use the on method and pass basic app as the next argument. The basic app is the method and the class that are defined in AQMP in the extension used by RabbitMQ for getting these publisher confirmations. Also, another callback that you can set when publishing is something called a basic return. So if a message can't be delivered for some reason, you'll get it back from the server if that's the case. And then you can set up a callback that gives you the returned message, and you can take whatever action that you need to in the case where a message is rejected.
Is there a timeout for that, or?
For rejecting messages or
return?
No, I don't think there's a timeout. You usually will find out right away if it can't be routed for some reason.
Okay.
Another thing you can do with timeouts, though, is you can set TTLs on the messages and even on the queues themselves. So the next task would be actually getting the data out of the queues. And for that, you use the basic consume method. And the basic consume method is very simple. You pass it the name of a callback that you're going to use for doing something with the messages. You give it a queue name, and you give it an optional consumer tag that can be used for figuring out which consumer is consuming what. If you have many of them, sometimes that's useful. Another way of setting up consumption is, as I mentioned, setting up this prefetch count, because defined in the AQMP protocol are consumer confirmations. So when you consume a message from the queue, you do something with it that's application specific, and when you're finished, you can send an acknowledgement back to the server, and that tells the server to get rid of that message from the queue. That's a little different from something like Kafka, where the consumers have to be a lot more intelligent and have to keep track of where they are in the stream that they're consuming from. In this case with RabbitMQ, if you just want to process a message and tell the server to delete it, it puts a lot more intelligence in the message broker itself, and it's very useful for many use cases. You can also do cumulative acknowledgements with these, and you can acknowledge many messages at once. But to control how many messages you're going to get at a time that are unacknowledged, you set a prefetch count, and then you just set up a basic consumer. And the consumer callbacks are pretty simple. You get passed the channel object, You get past 2 dictionaries of metadata, and then you get past the data from the queue itself. Something cool that you can do, I mentioned acknowledgements. You can also do negative acknowledgements in RabbitMQ, and that's through the basic NAP method. Something that RabbitMQ lets you do is set up what are known as dead letter queues. So when you send a negative acknowledgement, if you want, you can reroute all of those messages to the dead letter queue and inspect them later, see why they're being aborted or rejected by the application, etc. So those are the main examples for the library. For future work, I would like to create a more formal benchmarking suite for testing it under high throughput, both consuming and publishing. Implement a full test suite. There's many test cases that are scattered throughout the spec. I'd like to implement a test case for all of those. Maybe support additional protocols. There's a few other messaging protocols that RabbitMQ supports, and then just some new features. Any questions?
I've got too many to answer, but I can.
We can talk after that. Sure. All right. Once again, the GitHub, github.com/flightaware/tclrmq. So free. I welcome any contributions, any feature suggestions. Put an issue on GitHub. Be watching it. It's going to be actively developed. So thank you for your time. Thank you for your attention.
Okay.